If you wish to make an apple pie from scratch, you must first invent the universe.
Okay, that's good. So let's go up. Okay, it's at 2.5. Now we have current flow.
We should have timed the heating element
Also.
to see how fast it would have gotten up to 300 at 3 amps.
And that's a great point. We ended up having to go to Lowe's again to get a different heating element, which ended up increasing the amount of current going through about 5 amps. But this was able to bring the temperature of the smoker up to 250 degrees within 30 minutes. Now, if you remember from the last video, we ended up having trouble with the MOSFET. We ended up switching from a MOSFET to a triac here in the circuit. This is a triac module that uses drivers, but the main difference between a triac and a MOSFET is that triacs are used for AC, MOSFETs are used for DC. Now, the reason why we had problems with the MOSFET was because when the source is greater than the drain voltage, then current will flow. Now for AC current, we have it goes up and then it goes down. You can see this here on this graph. Now when it's going up on the first half cycle, the drain voltage is positive, the source voltage is negative. But on this down slope, we end up having a negative voltage on the drain, a positive voltage on the source. Current's going to flow because of the properties of the MOSFET. Now this is for an N-channel MOSFET, which is exactly what's shown here on the picture, and this meant that every half cycle the MOSFET would turn on, but in our eyes it never turned off. So that's why we had to switch to a triac, which allows us to do the same properties as the MOSFET, but it's doped in more regions, which allows the AC current to stop being flown from one side to the other, no matter what it sees, as long as the gate terminal gets its required voltage.